You have been told your entire life that nothing can move faster than light. It's the ultimate speed limit, the cosmic law, the boundary written into the fabric of reality itself. Einstein proved it. Physicists measure it. Every experiment confirms it. 186,000 miles per second. The fastest anything can ever go. And you believe this. Of course you do. It's in every textbook, every documentary, every explanation of relativity. But here's the problem with that confidence. Right now, this very moment, there are galaxies racing away from you at speeds that make light look like it's standing still, not breaking the speed limit, doing something far stranger. What if the universe found a loophole? Let's start with something you can see. You're standing outside at night. The sky is clear. You look up and see stars, thousands of them, points of light scattered across the darkness. Some are bright, some are dim. Some form patterns your ancestors named and told stories about. And every single photon of light that enters your eye has traveled for years, decades, sometimes millions of years, crossing the vast emptiness of space at the fastest speed nature allows. Light moves. You can measure it. Time how long it takes to bounce off the moon. Clock it as it travels from the sun to Earth. Watch it cross a laboratory in billionths of a second. It always moves at the same speed. Exactly 186,282 miles per second in a vacuum. Not approximately. Exactly. This speed is special, fundamental. It's not just how fast light moves. It's the speed at which causality itself propagates, the speed at which information can travel, the speed at which the universe connects cause to effect. Nothing moves faster. Your intuition accepts this easily. It feels right. There should be limits. There should be rules. The universe should have boundaries. And for most of human history, this made perfect sense. In the 1920s, an astronomer named Edwin Hubble was studying distant galaxies through the most powerful telescope available. He wasn't looking for anything revolutionary. He was just measuring, taking data, recording observations. He studied the light from these galaxies, analyzed their spectra, the fingerprints of elements glowing in their stars, and he noticed something odd. The light was wrong. Not dim, not distorted, but shifted. Every wavelength was stretched. The blue light looked greener. The green looked redder. The red looked infrared, as if the light itself had been pulled, elongated, stretched during its journey across space. This is called redshift. And Hubble saw it in galaxy after galaxy after galaxy. But here's what made him stop and think. The farther away the galaxy, the more stretched the light became. Nearby galaxies? Slight redshift. Distant galaxies? Massive redshift. Extremely distant galaxies? The light was stretched so much it barely looked like light anymore. This pattern was too clean to be coincidence. Too consistent to be error. Scientists noticed something was wrong. Now, there was an explanation for redshift. A simple one. When something moves away from you, the waves it emits get stretched. Sound does this. You hear it every time an ambulance passes. The siren's pitch drops as it speeds away. Light does the same thing. If a galaxy is moving away from you, its light gets redshifted. So, Hubble's observation suggested something straightforward. Galaxies are moving away from us, all of them, in every direction. The farther away they are, the faster they're receding. But this created a problem. Because when you calculated the speeds based on the redshift, something impossible emerged. The most distant galaxies weren't just moving away quickly. They were moving away at speeds approaching the speed of light itself, and some appeared to be moving even faster. This should have been impossible. Einstein's special relativity was clear. Nothing with mass can reach the speed of light, let alone exceed it. The energy required approaches infinity. The laws of physics prevent it absolutely. And yet the observations were undeniable. Hubble published his findings in 1929. The universe, he concluded, is expanding, not moving through space. The space itself is expanding, growing, stretching, carrying galaxies along with it. This wasn't a theory anymore. This was measurement. This was what the light from distant galaxies was screaming at anyone who looked carefully enough. There was no going back. Let me make sure you understand what this means. You think of the universe as a container, a big, possibly infinite space where galaxies float around like boats on an ocean. But that's not what the universe is. Space is not a container. Space is not a stage where matter performs. Space itself is a thing, a physical thing. It can bend, it can ripple, it can stretch, and it is stretching. Right now, everywhere, all the time. Between you and the nearest galaxy, space is expanding. Not much. The distances are so small and the expansion so gradual that gravity easily holds things together. But between you and a galaxy a billion light-years away, space is expanding faster, much faster. Between you and a galaxy 10 billion light-years away, space is expanding so fast that new space is being created between you and that galaxy faster than light can cross it. Think about that. Light is trying to reach you. It's moving at the cosmic speed limit, 186,000 miles per second. But the space it's traveling through is expanding. New space is appearing between the light and you. The light is making progress, but the finish line is moving away faster than the light can catch up. This should bother you. Now here's where it gets truly strange. Einstein's speed limit says nothing can move through space faster than light. No particle, no object, no information. That law is ironclad, tested, confirmed, built into the structure of causality itself. But the universe found a loophole. Space itself isn't moving through space. Space is expanding, creating more of itself. And there is no speed limit on that. None. The universe doesn't care. There's no law against it, no constraint, no boundary. Space can expand as fast as it wants. In fact, it's accelerating. The expansion is getting faster over time. Galaxies that are already receding at incredible speeds are receding faster and faster with each passing moment. Right now, there are galaxies, visible in our most powerful telescopes, that are receding from us at speeds exceeding the speed of light by factors of 2, 3, 10, 100. They're not breaking the cosmic speed limit. They're not even subject to it, because they're not moving. The space between us and them is growing, and that distinction makes all the difference. Let me give you an image. Imagine ants on the surface of a balloon. They can walk around, crawl from one spot to another. There's a maximum speed they can move across the rubber. That's their speed limit, their cosmic law. Now start inflating the balloon. The ants can still only walk at their maximum speed across the surface. That hasn't changed. The law still holds. But ants on opposite sides of the balloon are now getting farther apart, faster than they could ever walk toward each other. Not because they're breaking the speed limit, but because the surface itself is expanding. The rubber between them is stretching. New surface is appearing. And there's no limit on how fast that can happen. This is the universe. We are the ants. Light is our maximum walking speed, and the balloon is inflating faster than we can ever cross it. Except it's worse than that. Because the balloon isn't just inflating, it's accelerating. The expansion is speeding up, and we don't know why. In the 1990s, astronomers were trying to measure exactly how fast the universe was expanding. They studied distant supernovae, exploding stars that shine with predictable brightness. By measuring how dim they appeared, you could calculate their distance. And by measuring their redshift, you could calculate how fast they were receding. The expectation was clear. The universe is expanding, but gravity should be slowing it down, like throwing a ball into the air. It goes up, but it's decelerating the whole time. The question was, how much is expansion slowing? Will it slow enough to stop? To reverse? Will the universe eventually collapse back in on itself? Or will it just keep expanding forever, gradually slowing, but never quite stopping? They ran the numbers, and what they found didn't make sense. The expansion wasn't slowing down, it was speeding up. Think about that. You throw a ball up. You expect gravity to slow it. Instead, it accelerates. Faster and faster, flying upward with increasing speed. That's not how gravity works. That's not how anything works, unless there's something else, some other force, some energy filling space itself, pushing everything apart. They called it dark energy. Not because it's dark, but because we have no idea what it is. We just know it's there. We measure its effects. We watch it accelerate the expansion of the universe. And it is winning. Galaxies that are far enough away are already receding faster than light. And every moment, more galaxies cross that threshold. Eventually, billions of years from now, every galaxy outside our local group will have receded beyond the observable universe. Their light will never reach us. They will disappear, not because they were destroyed, but because the space between us and them grew too fast for light to ever cross. The universe won't go dark gradually. It will simply erase itself from view, one galaxy at a time, until we are alone in an expanding void with nothing to see but the fading remnants of our own cosmic neighborhood. This is measured. This is confirmed. This is happening right now. So let's go back to the question. How can anything move faster than light? The answer is, it doesn't. Not the way you think of movement. When you move, you push off against something. You interact with space. You traverse distance. You go from one location to another. Galaxies receding faster than light aren't doing that. They're not moving through space. Space itself is expanding between us and them. From the galaxy's perspective, it's perfectly still. Its local space-time is fine. Particles within that galaxy still obey the speed limit. Light still moves at light speed. But the metric of space, the actual distance between points, is increasing. And there's no limit on how fast that can happen. This isn't a loophole in the law. This is the law correctly understood. Einstein's relativity says nothing can move through space faster than light. And nothing does. But space itself is not bound by that constraint. The universe won't let you accelerate a particle past light speed. The energy cost becomes infinite. The structure of causality prevents it. But the universe has no problem creating new space, expanding the distances between things, making the cosmos larger, faster, without limit. There's a wall, an absolute boundary. You cannot cross it by moving, but the universe can move the wall. It can stretch the racetrack while you're running. It can add distance faster than you can cover it, and there's nothing you can do about it. This is not negotiable. Here's what should genuinely unsettle you. This isn't about galaxies. This isn't about cosmology or telescopes or redshift. This is about the structure of reality itself. You think of space as empty, as nothing, as the absence of things. But space is something. A flexible, dynamic, expandable fabric that has its own properties, its own behavior. Space can curve around massive objects. It can ripple when those objects accelerate. It can expand, carrying everything embedded in it along for the ride. And we, humans, Earth, the solar system, the galaxy, are embedded in it, not floating through it, embedded in it, like fish in water. We don't see the water. We see through it. We move through it. But it's there, shaping everything we experience. Space is the water, and the water is getting deeper, faster. This isn't a rule. This is how reality is built. Now think about what this means for us. For most of human history, we thought we could see everything. Eventually, given enough time, enough patience, enough powerful telescopes. But that's not true. There is a horizon, an edge beyond which light will never reach us. Not because the light isn't there, but because the space between us and it is expanding too fast. There are galaxies, billions of them, that exist right now, but whose light will never reach Earth. Not in 1,000,000 years. Not in 1,000,000,000,000 years. Never. Not because they're too far, but because they're receding too fast. They are causally disconnected from us. They exist in our universe, share the same space, obey the same laws. But we will never see them, never interact with them, never know they're there except through inference and theory. And every day, more galaxies cross that threshold. The observable universe is shrinking. Not because galaxies are being destroyed, but because they're slipping beyond the edge of what light can ever traverse. We are watching the universe erase itself from our view. Slowly, inevitably, permanently. This is measured. This is confirmed. This is not speculation. Your descendants, billions of years from now, if they exist, will look up at a sky much emptier than ours. Most of the galaxies we can see will have vanished beyond the horizon, and the astronomers of that distant age will have no way of knowing there was ever anything else out there. They will measure the universe and conclude it consists of one galaxy, theirs, surrounded by endless void. And they will be wrong. But they'll have no way of knowing. Richard Feynman understood something crucial about physics. He understood that the universe doesn't care about our intuitions. It doesn't care about what makes sense to us. It doesn't care about our comfort. It simply is what it is. And our job, as curious, pattern-seeking creatures, is not to impose our expectations onto reality, but to observe, to measure, to follow the evidence wherever it leads, even when it leads somewhere deeply uncomfortable. Feynman would look at the expansion of space and see it not as a violation of the cosmic speed limit, but as a clarification of what that limit actually means. The speed of light is the speed of causality, the speed at which information can propagate through space, the speed at which local interactions unfold. That limit is absolute, ironclad, built into the structure of reality. But space itself is not local. It's global. It's the arena where local interactions happen. And there's no law governing how fast the arena can change size. So the universe expands, faster and faster, accelerating, creating new space, stretching the distances between galaxies. And the speed limit, the real speed limit, remains intact. Nothing moves through space faster than light. But space itself moves however fast it wants. Let's trace how we learned this. Ancient humans looked up and saw stars. They assumed the stars were fixed, eternal, unchanging. Then we built telescopes. We measured distances. We realized stars were moving, rotating around the galaxy, drifting through space. Then we measured other galaxies. We saw they were moving too, and not randomly. They were all moving away. Then we looked deeper, farther. We found galaxies receding at impossible speeds. Then we measured more carefully. We discovered the expansion is accelerating. Each answer revealed a new question. Each observation demanded a deeper explanation. This is how science works, not through sudden revelations, not through lone geniuses seeing what no one else could see, but through accumulated observations, careful measurements, brutal honesty about what doesn't fit. One astronomer measures stellar distances. Another measures their motion. Another measures their light. Another calculates their speed. Another notices the pattern. Another builds the theory. Another tests the predictions. Another finds the anomaly that demands refinement. It's an avalanche. Each discovery makes the next one possible. Each answered question exposes new terrain. We are still climbing, still measuring, still finding new edges where understanding breaks down. And the universe keeps surprising us. So here's the truth. There are things in the universe moving faster than light. Not particles, not objects, not information, but space itself, the fabric, the substrate, the arena where everything happens. It expands. It accelerates. It carries galaxies away from us faster than light can ever catch up. And there's nothing anyone can do about it. You cannot stop the expansion. You cannot slow it. You cannot reverse it. The universe is getting larger. The distances are growing. The horizon is shrinking. And in the unimaginably distant future, when the last stars have burned out and the last black holes have evaporated, the universe will be so vast, so empty, so cold, that nothing will ever interact with anything else ever again. Not because matter was destroyed, but because the space between everything grew too large for anything to ever reach anything else. Eternal, absolute, irreversible isolation. This is the fate of the cosmos. Not a theory, not a guess. A prediction based on what we observe right now. Sit with that for a moment. The universe is not static. It's not stable. It's not waiting for us. It's expanding, accelerating, erasing itself from view. And the mechanism it uses isn't exotic. It's not a strange particle, or a hidden dimension, or a quantum fluctuation. It's space itself, the most fundamental thing there is, the background against which everything exists. Space doesn't obey the speed limit, because space isn't moving. It's growing, and growth has no maximum speed. This isn't a loophole. This is the law correctly understood. Einstein's relativity is intact. The cosmic speed limit is real. Nothing moves through space faster than light. But space itself is not bound by that constraint. And so the universe expands, faster than light, 100 times faster, 1,000 times faster in the most distant regions. And there's nothing, no technology, no physics, no force that can stop it. This is not negotiable. This is how reality is built. You started this thinking the speed of light was the ultimate limit. And you were right, but you were also wrong. Because the universe is larger than that limit, more flexible, more strange. It found a way to move faster than light without breaking the rule. Not through cleverness, not through violation, but through a deeper understanding of what the rule actually means. The speed of light governs motion through space, but nothing governs space itself. And now you know. The universe is not obligated to make sense to you. It doesn't care about your intuition. It doesn't care about your comfort. It simply expands, accelerates, grows, carrying galaxies beyond the edge of forever. While you stand here, tiny and temporary, watching it happen, unable to stop it, unable to follow, only able to observe, to measure, to understand. The universe is faster than light, and it's leaving us behind.